Hello, today I will be showing to you our C++ implementation of the first come first serve and shortest job for CPU scheduling algorithms. The IDE that we used is CodeBlocks, which is an open source and cross-platform IDE for C and C++. First, let's take a look at what our program does. So what we did was a console program, so let's launch it. The first thing that it does is ask the user the file name of the input text file. This file should be in the same folder as the executable file, or else the program will not be able to detect it. The input file has a specific format that should be followed for the program to execute properly. The first line should contain the number of test cases for that file. The next lines contain the different CPU scheduling algorithms indicated by the abbreviations, such as FCFS, SJF, SRTF, and others. The number beside the abbreviations is the number of processes for that particular scheduling algorithm. The next lines are the processes. For each process, there are three numbers. The first is the arrival time, the second is the burst time, and the third is the level of priority. So now let's try out the program. First, we enter the file name. If we enter a name which does not exist, the program will output this. If the program successfully reads and processes the file, the program will output CPU scheduling done, and we should see a new text file called output.txt. This file contains the CPU schedule output, and it also has a specific format. So let's take a look at that. The output of each algorithm starts with a test case number, which is then followed by the CPU schedule. The first number indicates the time that has elapsed so far in the CPU scheduling. The second indicates the process that is currently running, and the last number indicates the time used by the process. The X at the end indicates that the process has finished running. Now I'll be showing to you the source code. First is the main function. We initialize a bunch of ints and strings in a string vector line. Here in these lines are the functions to enter the file name. To access and output text files, we use the ifstream and offstream subclasses of the fstream class. When the file exists and is open, the program will put the contents of each line of the text file in the vector line. And this continues until the end of the file. If the file does not exist, the program will terminate. The next line creates the output file, or opens the file if it already exists, and clears its contents using the truncate function. Next, we have a for loop, which scans the contents of the vector line from the second line of the file until the last line. If the program encounters an FCFS or SJF substring, it will execute this set of code. If the program detects an SRTF, P, or RR substring, the program will simply increment case counter, which contains the test case index. So going back to FCFS and SJF, case counter will increment and we put its current value to the output file. Next, we get the number of processes for that particular CPU scheduling algorithm by getting the line containing the number of processes and the scheduling algorithm. We extract part of this string from the start of the string and until it encounters space. Since this part is a string, we convert it into an int using the a to I function. After this, we then initialize a 2D int array with the number of rows equal to the number of processes and 4 columns, one of each for the arrival time, burst time, priority, and the process index. Two for loops are used to put the contents of the vector line to the array. A string stream is used to extract the numbers in the line and put into their respective columns. For the last column, the process index is simply 1 plus the current index of the for loop. Next, we check again what the scheduling algorithm is. If it is FCFS, the FCFS function will be called. And if SJF, the SJF function is called. For both of these functions, there are two arguments, the number of processes and the 2D array. Now let's take a look at the FCFS function. 4 ints are initialized: elapsed time, use time, count done, and index. Elapsed time is the time that has elapsed so far in the scheduling. Use time is the total time that was used by the process. Count done is the number of processes that has finished running. and index is a container of the process index. We open the output file to start putting in the values. There is a first while loop which checks whether the number of finished processes is less than the total number of processes. Count done increments every time this loops. Inside is another while loop which checks the value of index. I will be explaining this later. Inside is a for loop which checks the contents of each process. Since this is FCFS, using the for loop ensures that the first processes are checked first. An if statement checks whether the burst time of the process is not equal to 0, and if the arrival time of the process is less than or equal to the current value of elapsed time. To distinguish what processes have finished running from those that have not yet run, what our program does is to decrement the burst time of the running process until it becomes 0, which is why we want to check if the burst time is 0. If it is 0, it means that the process has already run and the program moves on to the other processes. Okay, so if both of these conditions are true, index will be set to the current value of I, and we break off from the for loop. Index will only have a value of 0 or greater if the conditions in the if statement are met. So for example, in this time frame, no process is available, so the conditions are not met, which means that the index will remain equal to -1. And so we increment elapsed time. This will increment until index is set to a value of 0 or greater. So next, when the index has been set, the program will break up from the while loop. Elapsed time will have an extra time, so we decrement it. We then output the current value of elapsed time and the process index, which are the first and second digits in the output. We then used another while loop to decrement the burst time and increment the elapsed time and use time. Since FCFS is non-preemptive, this will go on until the burst time becomes 0, until the process is done. Use time is then put into the output file, followed by a string x to indicate the end of the process. Count done is incremented, use time is reset to 0, and index is reset to -1. The while loop continues until all processes have been completed. The output file is then closed and the function finishes, and the program goes back to the main function. For the SJF function, it actually does the same process as the FCFS function, except that at the start, the processes are rearranged by ascending burst time. So let's take a look. Same with the FCFS function, these ints are initialized. 4 additional ints are initialized. These are temporary containers of the arrival time, burst time, priority, and process index of the processes. 2 for loops and an if statement are used to compare the burst times of the processes. The two processes will swap places either when the first process has a bigger burst time than the second, or when both have equal burst times but the first has a bigger process index than the second. Swapping is done by first putting the values of the first process into the temporary containers. Then the values of the process will be overwritten by the values of the second process. And finally, the values of the second process will be overwritten by the values of the first process using the temporary containers. When the processes have been arranged, we then implement the same algorithm as the FCFS. This works because what the program does is run the shortest available process first. When all the processes are finished, the output file closes and the program goes back to the main function. When all the CPU scheduling algorithms are done, the program outputs this, and the program terminates. Let's take a look at some examples. Here we have 2 processes and we implement the first come first serve algorithm. The Gantt chart of the processes should look like this. For clock cycle 0 to 9, no processes are running. At clock cycle 10, P2 will run for 70 cycles. So the expected output should look like this. 10 as the elapsed time so far, the process 2 as the currently running process, and 70 as the time used by the process. Since P1 is not yet available, the program waits until elapsed time becomes equal to 100. At clock cycle 100, P1 runs for 10 cycles. Here's another example for the shortest job first algorithm. At time cycle 0, only P1 is available, so it runs for 100 clock cycles. At clock cycle 100, all the other processes are available. P4 has the shortest burst time, so we execute it first. This is then followed by P2 with a burst time of 20, and finally P3 with a burst time of 30. There are more examples of the FCFS and SJF algorithms, their Gantt charts, and the expected outputs, which you can compare with the output file generated by the program.